Hello, everybody. So in today's lesson, we're going to be talking about volume of rectangular prisms. We are on page 427 of the 6th grade Go Math textbook for middle school. So let's go ahead and get started. So using fractional edge lengths. So a cube with edge length, 1 unit, and a volume of 1 cubic unit is filled with smaller cubes as shown. All right, so what they're telling us is that this side length is 1, this is 1, and the height is 1. Well, 1 times 1 times 1 is 1 unit cube. So they're going to take this volume that is 1 cubic unit, and they're going to fill it with these smaller cubes. Well, then each cube is not 1. Each cube is 1/3, right? Because 1/3 plus 1/3 plus 1/3 is 3/3, or 1. Okay, so how many small cubes are used to fill the large cube? And well, if it takes me 3 small cubes, right, 1/3 plus 1/3 plus 1/3, it'll be 1/3 plus 1/3 plus 1/3 here, and 1/3 plus 1/3 plus 1/3. So that's 3 times 3 times 3. So that would take me 27 small cubes. So what's the volume of one small cube? Well, we know that volume equals length times width times height, right? And so if we figure that out, so since 1 cube is 1/3 of the side length, then 1/3 times 1/3 times 1/3 would be 1/27 of the total volume. What is the edge length of one small cube? Well, we already talked about it, 1/3 unit. So the formula for the volume of a cube with side length is L is volume equals length times length times length, or volume equals length to the third power. Find the volume of one small cube using this formula. Well, we already did that. Okay, so we could say 1/3 to the third power, which is, again, 1/3 times 1/3 times 1/3, which is 1/27. So what is if you compare the volumes found in D with what we found in B, they're going to be the same, right? Right, suppose a cube has a side length of 2/3 unit. If you fill this cube with the smaller cube shown above, how many smaller cubes would you need? All right, so what we're telling us now, instead of 1 unit, we're going to call this 2/3 unit. So the volume of that in that case would be 2/3 to the third power, right? If each side length of this large cube is 2/3, so they want to know how many 1/3s would fit in one of these smaller ones. Well, if each of the smaller cubes, 2/3 times 2/3 times 2/3, that would be 8/27. So it's going to be 8 small cubes. And the volume is 2/3 which is the same as 2/3 times 2/3 times 2/3, which is 8/27. Ben says the volume of a cube with edge length 3/4 unit is 3/4 the volume of a unit cube. Do you agree? No. So 3/4, what they're saying is each of the little squares is 1/4. 1/4 plus 1/4 plus 1/4. So if we figure that out, we'd go volume equals 3/4 to the third power. 3/4 times 3/4 times 3/4. 3 times 3 times 3 is 27, because 3 times 3 is 9, and 9 times 3 is 27. 4 times 4 is 16, and 16 times 4 is 64. So it's actually 27/64 the volume of a unit cube. All right. So a rectangular prism has 6 faces, right? And it doesn't really matter which two opposite sides we call the base. As long as so I could call the front face and the back face the base. I could call the bottom and the top the base. I could call the sides the base. So it really doesn't matter. You're still going to get the same volume. Okay, so volume equals length times width times height, or volume equals base, capital B, where the capital B equals length times width times the height. So example 1, use the formula volume equals base times height. Choose one face to be a base and find its area. So here they're saying the base is going to be the bottom. So they're using 3 times 2 and 1/4. Well, 2 and 1/4 is the same as saying 9/4, right? 2 sets of 4/4 is 8. 8 plus 1 is 9, so 9/4. And 3 times 9/4 is 27/4. So the base is 27/4. So as we go up 4.5 meters, it's going to take up 27/4 of a meter going all the way up. So 27/4 times the height would be 27/4 times 9/2. 4 times 2 is 8, plus the leftover half is 9/2. 27 times 9 is 243 over 8. If we divide that out, we come up with 30 3/8. So we can check that by doing 243 divided by 8. Well, 8 times 3 is 24, which leaves us nothing. So we bring down the 3 ones, and I can't take any 8s from 3, so that's going to leave me with a remainder of 3. So 30 3/8. All right, number 3. In step 1, why does it make sense to leave the area of the base as an improper fraction? Well, sometimes it's just easier to multiply using improper fractions. So in step 2, the base is multiplied by 4.5 inches. All right, so remember when we're multiplying two mixed numbers, like 27, I'm sorry, B 27 fourths is being multiplied by a mixed number. So to multiply a mixed number, sometimes it's easier to just change that mixed number into an improper fraction and then multiply. Okay. Otherwise, we'd have to multiply 27 fourths by 4 and then multiply 27 fourths by a half to get that. Or you'd have to change 4.5 to a decimal. Okay, so it just makes it easier to do the mathematics. All right, number 4 on page 429. Find the volume of each rectangular prism. Okay, so we know that the formula is base times height or length times width times height. All right. So again, it doesn't matter which ones we call the base. You can choose these two to be multiplied as being the base. We can do these two. So whatever you want to do. All right, so that's what I'm going to do. All right. So I'm going to change these to improper fractions. 7 1/2 is 15 halves. 7 times 2, so we have 7 halves. That's 14. Plus 1 left over is 15 halves. Times 4 times 2.5. 2.5 is the same as 5 halves. Okay, so then remember 4 is the same as 4 over 1. I see that I can reduce these two by dividing by a factor of 2. So now we have, you notice that these two, the 2 and the 2, that can also be reduced by a factor of 2. So we're left with 15 firsts times 5 firsts. 15 times 5 is 75 over 1, which is the same as 75. So 75 cubic inches. Right, B. Volume equals 5 1/4 times 3.5 times 3. Length times width times height. Change it to the improper fraction. 4 times 5 is 20, plus the extra 1/4 is 21 fourths. Times 3.5 would be 3 times 2 is 6, plus the extra half is 7 halves, times 3 over 1. All right, let's see if we can reduce anything. 4 is not a factor of 7. 4 is not a factor of 3. 2 is not a factor of 21. 2 is not a factor of 3. So no, we can't actually simplify anything here. So let's just multiply straight across. 4 times 2 is 8. 8 times 1 is 8. 21 times 7 is 147. And then multiply 147 by 3. So 441 eighths. So we want to turn that back into a mixed number now. So 441 divided by 8. So we get 55 whole as the whole number, and we have 1 left over, so 55 1/8 cubic inches. Okay, the next section, solving volume problems. So when we solve a real world problem involving the volume of a prism, you can choose to either use either volume formulas, So a terrarium is shaped like a rectangular prism. The prism is 25 and a half inches long, 13 and a half inches wide, and 16 inches deep, which is the same thing as saying height. The height is 16 inches. What's the volume of the terrarium? Well, choose one side to be the base and find its area. So here they chose 25 and a half and 13 and a half. They changed them to improper fractions. 25 times 2 is 50, plus one more is 51 halves, times 13 and a half, which is 13 times 2, 26, plus the leftover 1 half is 27 halves. If you multiply that out, you get 1,377 fourths. Now multiply that by the height, or the depth of the terrarium. So it's 1,377 fourths times 16. Well, 16 can be written as 16 firsts, and we can see that there's a common factor of 4. So simplify that out. 4 divided by 4 is 1. 16 divided by 4 is 4. Multiply 1,377 by 4, and we get 5,508 over 1, or 5,508. So that's the volume, 5,508 cubic inches. All right. So a rectangular swimming pool is 15 meters long, 10 and a half meters wide, and 2.5 meters deep. What is its volume? Okay, either use base times height, or volume equals length times width times height. So 15 times 10 and a half times 2.5. 15 is the same as 15 over 1. 10 and a half. So 10 times 2 is 20, plus one more is 21 halves. And 2.5 is the same as 2 times 2 is 4, plus one more is 5. So 5 halves. All right, so 2 is not a factor of 15. 2 is not a factor of 5. 2 is not a factor. So I can't reduce this any. So multiply straight across. 2 times 2 is 4. 4 times 1 is 4. All right. 15 times 21 is 315. So 315 halves times 5 halves. 315 times 5. 1,575. Okay, we want to change this back into a mixed number. So 1,575 divided by 4. So we get 393 with a remainder of 3. So 393 and 3/4 cubic meters. Okay, let's move on to page 430, and let's look at the guided practice. So the cube shown has an edge length of 4/5 unit and is filled with smaller cubes. How many small cubes are there? All right, so we have 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. The volume of the large cube is how much cubic units? So 4/5 times 4/5 times 4/5. Well, 5 times 5 times 5 is 125. And we know 4 times 4 times 4 is 64. So 64 125th cubic unit. Number 3. Find the volume of each prism. So if we call the volume of this 10 meters, the length 10, the width 3 2/10 meter, and the height 5 meters. Okay, well 10 times 3.5 is 32. So 32 times 5. 32 times 5 would give me 160 cubic meters. Number 4, 7 1/4 times 4. So they want us to find the base in this case. Okay, so I'm going to choose this as my base. There's no right or wrong answer. You could also do 8 times 4 as your base. Okay. You could do 7 1/4 times 8 as your base. All right, so 7 1/4 times 4. 7 times 4 is 28, plus 1 more is 29/4 times 4 over 1. Okay, well, there's a greatest common factor of 4, so go ahead and reduce. So 29 times 1 is 29. 1 times 1 is 1. So that leaves us with 29 meters squared. Now we're going to multiply this 29 by 8. So 232 cubic meters. Okay, number 5. So again, use either method, the base times height or length times width times height. And basically, we're doing the same thing no matter what. All right, so I'm going to go ahead and do this on scratch paper so we have plenty of room. I'm going to start by writing the equation or the formula that we're going to use, and I'm going to substitute the values. So 9.25 times 4 times 7.5. All right. So 9 and 25 hundredths is the same as 9 and 1/4. Okay. 4 is the same as 4 over 1, and 7 and 5/10 is the same as 7.5. Okay, so that's one way we can do it. We can change these values into fractions, or we could just multiply across. So let me go ahead and finish up the fraction part. Okay, so all I did was change the mixed numbers into improper fractions. 9 times 4 is 36, plus 1 more is 37. I just brought down the 4 times 4 firsts, and 7.5 is the same as 15 halves. There's the greatest common factor of 4 in 37 fourths and 4. And so 37 times 15 equals 555 over 2. With a remainder of 1. So 277 and 1/2. Which is also the same as 277.5 cubic feet. Okay, because if we multiplied 9.25 times 4. We would have gotten 37. Okay. 37 times 7.5. Okay. So either way, you could have just multiplied it out as the decimals. Okay. So 9 and 25 hundredths times 4 would have given you 37. Then take the 37, multiply by 7.5, and we would have came up with 277.5. Either way would give us the right answer. All right, number 6. Okay, so volume equals length times width times height. Volume equals 18 times 4.5 times 6.5. All right. So 18 can be rewritten as 18 over 1. 4.5 is the same as 9 halves. 4 times 2 is 8, plus 1 more is 9, 9 halves. And 6.5 is the same as 13 halves. 6 times 2 is 12, plus 1 more is 13. All right, so we have 18 firsts times 9 halves. Well, I see that the common factor of 2 and 18 is 2. So I can reduce that by dividing by 2. All right, now the other 2 is not a factor of either of those. So let's go ahead and just multiply across. So we get 9 times 9 is 81 firsts times 13 halves. 81 times 13 is 1,053 over 2. So 81 times 13 is 1,053. 1 times 2 is 2. Change that back into a mixed number by dividing the numerator by the denominator. So we get 526 with a remainder of 1. So 526 and a half. Which is also the same as saying 526.5. All right, number 7. Cereal box is 8.5 inches long, 3.5 inches wide, and 12 inches high. What's the volume of the box? Right. So again, they told us it's 8.5 inches long, 3.5 inches wide, and 12 inches high. All right. I'm going to change these into improper fractions. 8.5 is the same as 17 halves. 8 times 2 is 16, plus 1 more is 17. 3.5 is the same as 7 halves. 3 times 2 is 6, plus 1 more is 7, 7 halves. And 12 is the same as 12 firsts. All right, so let's see if we can reduce anything. Two is a common factor of 12. Okay, so I'm going to simplify 12 by dividing by 2, which gives me 6. All right, so now 17 times 7 is 119 halves times 6 over 1. 119 times 6 is 714 halves. Turn that into a mixed number. We actually get no remainder, so 357 cubic inches. All right, and number 8. Which two formulas can you use to find the volume of a rectangular prism? Why are these two formulas equivalent? Okay, well, we could say length times width times height, or volume equals the base times the height. Okay, so those are the two formulas. Why are they equivalent? Well, because the base is length times width, right? So that would be, they're both being multiplied by the same height. So they're equivalent equivalent equations. Okay, again, all they're doing is taking the length times width and saying, oh, that's the base. Okay, the base of a rectangular prism is the area of one of the faces. Well, an area is found by length times width. So L times W is the same or is equal to the base, or B, in the other formula. And they're both being multiplied by H. All right, so that's it for this first part. So in the next video, we'll talk about the independent practice problems. So until then, I will see you soon.